Daily Work Unit 3.1. It says, tell whether the following are parallel, skew, or neither. And so it says XQ, there's XQ, RZ. They both lie in the plane of the top of the rectangular prism. They do not intersect, so they're two non-coplanar lines. Excuse me, that was wrong. They are two coplanar lines. There we go. Two coplanar lines that never intersect, therefore they are parallel. Number two. Number two, we have HF, which is here. We have EB, which is here. So again, what you're going to do is you're going to see where they're at, even draw them if you need to, and make that decision. That is two coplanar lines. They both lie in the plane of the bottom. They never intersect. So you can finish that. F, B, and EB. You can just look at how they're named and tell something about those two, right? What are they going to do without even looking at the picture when you realize that, okay? And so then we have XH and EB, XH and EB. Let's take a look at those two. There's XH, here's EB. Those do not lie in the same plane. One lies in the plane of the left and one lies in the plane of the right. They never intersect though, so here we have two non-coplanar lines that never intersect, two non-coplanar lines that never intersect, and so we say that those two are skew. XH and EB are skew lines. Okay? Now remember that we only use the word skew for two lines. You would never use the word skew for two planes, nor would you use the word skew for a line and a plane. So a line and a plane will either never uh, intersect, which we would say parallel, or they do intersect, which we would say neither, as far as parallel or skew. And then obviously they would intersect, okay? And you can finish that. Name the special pairs of angles and identify their transversal. Remember that a transversal is a line that intersects two or more coplanar lines in different points. And so we're talking about angle 2 and angle 5 here. Remember that an angle is a figure formed by two rays with the common endpoint. So we would look at the vertex of angle 2, that common endpoint, and we would draw the two rays. And we're just going to kind of go to where it hits another corner. We know that in reality the angle goes infinitely forever because it's formed by two rays. And then angle 5, its vertex is right here. One ray goes up here and we'll stop at the vertex of 2, and then the other ray goes here. When you put that together, you see the Z, and we kind of put some letter association to those special pairs of angles. The names of those special pairs of angles, remember, are alternate interior angles, corresponding angles, and same side interior angles. And we put letter associations. We said alternate interior angles make a Z, corresponding angles make an F, and same side interior angles make a C. Now, we have formal definitions that we really should know. We say that alternate interior angles are two non-adjacent interior angles on opposite sides of the transversal. Corresponding angles are two angles in corresponding positions relative to the two lines, and same side interior angles are two interior angles on the same side of the transversal. Looking at 2 and 5, though, visually what we're going to see is the letter Z. So we would say that they are alternate interior angles. You can do some abbreviating. The two lines that form them are the two that are intersected by the third one. Remember, the transversal, and I'll color code it in green because we underlined it up there in green, is the one that intersects the other two in different points. So the transversal is AE. It contains the point A and the point E. The lines are line AG and line CE. Any questions on number 9? Okay, let's just do number 11. Angle 1 and angle 8. Angle 1 and angle 8. So we will find the vertex of angle 1. Let me let that go off. You probably see that I made a mistake. That's an angle. That's an A right there. And I drew that line. This should be line HG. HG right there. You may have noticed that earlier. Okay. And I called that bottom one CE, and it's really not CE, it's CD. I had a lot of stuff in the way. So the lines here for number 9 were line HG and line CD. And the transversal was line AE, which we could have also called line HE. Okay? All right, let's look at the next example. Or number 11, excuse me, angle 1. So we would find the vertex of angle 1 and then the rays that make the angle. And then we have angle 8. So here's the vertex of angle 8, and here's one ray. And then here's the other ray. You can see that they make the letter C. Same sides make a C. Same sides make a C. And so they're same side interior angles. The lines that form them are here, line BC and line GF, line BC and line GF. And remember again, the transversal is the one that intersects the other two, which is line HG. And you can do the others on your own. Any questions on that section? So again, you need the formal definitions, and we also would like for you to know the visual aid that alternate interior angles make the letter Z, same correspondings make the letter F, and same side interiors make the letter C. Okay. Now, the rest of this is discovery learning, and we want you to use a protractor, and I'll show you a little bit of how to use a protractor. And I really encourage you to do these. I encourage teachers to encourage their students to do it, and I encourage the students to do it because this gives you a visual of what the rules you're fixing to learn actually look like and why they are what they are. It also allows you to learn how to use compasses and protractors and rulers, which we need to know how to do, okay? And so I'm going to kind of show you what you're supposed to do. If we were going to measure angle 4, what we would do is take a protractor, which measures degrees. You would lay it here such that the little hole in the protractor or the 0 setting there. Sometimes the actual bottom of the protractor goes here like that, and then you've got a hole in it where the vertex would be, and you've got 0 degrees here. And what you would do is find where that hits the protractor and then see the measure of the angle. So it should be 10, 20, 30, 40, 50, 60, 70, 80, 90 there, a little over. And so you'll get whatever angle 4 is. And I'm not going to measure it exactly. You can actually see what that is. But what you're going to find is that when the lines are parallel, you're going to find that when the lines are parallel, then, excuse me, my smartboard was catching up there for just a second. I apologize for the delay. Then those two angles right there are going to be congruent. The way we show parallel is arrows inside the lines themselves. Those are corresponding angles. And so we're going to reach the conclusion here that if the lines are parallel, then the corresponding angles are equal. And if they're not parallel, then corresponding angles are not equal. And we'll do similar things with the other uh, angles, alternate interior angles, same side interior angles. We're not going to conclude that same side interior angles are equal, though there'll be another conclusion. Now, here's how this works. The student will draw, label, construct, calculate, and reach a conclusion. Now, for students and teachers both, this is a big hint. I would have students halfway through the year who would still have trouble figuring out what the conclusions are. The conclusions are always the rules on the next page. So it's not going to be real hard to know what goes in the blank right here. Because if you go to the next lesson, it's going to say properties of parallel lines, corresponding angles are, and your student edition will say equal. And so in the last part of the homework in Unit 3.1, we have some construction method of discovering that corresponding angles are equal, alternate interior angles are equal, and same side interior angles are supplementary. After using a protractor and discovering it, then we will say, well, here's a rule. Now, these rules can be proven in two-column proofs, but what I've chosen to do most of the time here is to let the student actually discover this using tools of construction so that they get that experience as well as an actual visual understanding of what the rule really means, okay? All right, so that's the end of 3.1 daily work video, and we will take a look at Unit 3.2 in a moment.